going down to secant, and then eventually cosecant. The graphs for secant and for cosecant are done off of what we call a guide function. Secant is the reciprocal of cosine. So what I will do is I will consider for just a second cosine graph before I graph the graph of secant. Okay, for cosine, the highest point I'd have is 1, the lowest point I'd have is negative 1. The quarter points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. The basic shape for cosine is I would have a point at 1, at 0, at negative 1, at 0, at positive 1. And what I will do here is what I'm doing is I'm saying I'm considering cosine of theta equaling x over r, the reciprocal of secant. I will dot this function because this is not the function I want to graph, but it's a function that I'm considering as a guide. It turns out that for secant, anywhere you have a 0 for cosine, there will be an asymptote. In other words, where does this graph of cosine cross the theta axis? It crosses the theta axis at pi over 2. So there's a vertical asymptote at pi over 2. It also crosses at 3 pi over 2. There's a vertical asymptote here. The graph of secant behaves exactly opposite as the graph of cosine. So the graph that we're wanting to draw here, what will happen on this far left side, where you have that point at positive 1, you will also have a point for secant, but instead of going down, you will go up and you will be pulled towards that asymptote. You go up to infinity. Remember what we talked about as far as the range of cosine. We said cosine must lie in between 1 and negative 1. For secant, we said that secant must be bigger than 1 or less than negative 1. In the middle, you will have a point here for secant, and then it will form kind of a parabola-shaped graph opening down. Over here, you will have a graph at 1. You will be pulled towards the asymptote here. Now, what we're not drawing is we're not drawing the continuation of the leftmost and the rightmost graphs. What those continuations would look like is something like this. Okay, we're not going to draw those particularly here because we're only wanting to draw one period, but you need to know that the graph of secant are these parabola-looking graphs here. Finally, for the graph of cosecant, this is very similar. As a guide, what we're going to do is we're going to consider the reciprocal function, which is sine of theta equals y over r, and we will use some of the information that we know about that function to graph cosecant. Sine goes up to 1 and down to negative 1. Okay, the quarter points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, sine starts at 0, 0. It goes up to 1, down to 0, down to negative 1, and back up to 0. I will dot this, indicating that this is my guide function. Anywhere that sine cross the x or the theta axis, there will be an asymptote. So there's a vertical asymptote at 0, a vertical asymptote at pi, and a vertical asymptote at 2 pi. Cosecant acts just the opposite of sine. So we'll have a point here, a parabola-looking shape opening up. We'll have a point here, a parabola-looking shape opening down. That concludes my lesson on the basic shapes of trig functions.